In this video, I want to have a look at calculating the angle between two intersecting lines. So if we want to find the acute angle between two intersecting lines, we can use this formula here. So we've got tan alpha, where alpha is the acute angle made when those two lines are intersecting, equals the absolute value of m1 minus m2 over 1 plus m1 times m2. So those m1 and m2s, m1 is the gradient of one of the lines, and m2 is the gradient of one of the other lines. Now this will always find the acute angle. Some questions though will ask us to find the obtuse angle, so that could be this one here. Now if we want to find the obtuse angle, we're going to go through and find the acute angle anyway. And then because we know it lies on a straight line, that means that the two angles are going to be supplementary. They're going to add to 180 degrees. So to find the obtuse angle, we're going to find the acute angle and then go 180 minus that answer to give us our obtuse angle. So unfortunately, at the moment, we can't prove this formula just yet because of the order of the topics that we're teaching you in extension. We need to learn all our mathematics trigonometry and then all of our extension trigonometry, and then we can prove why this formula is working. So unfortunately for now, you just have to trust me that it is going to find the acute angle. So you need to remember this formula and you need to understand how to use it. And we will come back and prove it later on once we know our trigonometry. All right, so let's have a look at an example. I've left our formula up in the corner to help us. Our question asks us to determine the size of the acute angle between the line 3x plus y equals 7 and 2x minus y equals 0. So the first thing we need to do is determine m1 and m2. So we're going to rearrange both of these equations into gradient intercept form, which means we want to make y the subject of the equation. So for this first one, we'd rearrange that to y equals minus 3x plus 7, which means that our m1 is going to be equal to minus 3. For this one here, we'd rearrange it into y equals 2x, which means that m2 is equal to 2. So now that we have m1 and m2, we can substitute into our formula. So we're going to have tan alpha is equal to the absolute value of minus 3 minus 2 over 1 plus minus 3 times 2. So that whole thing, the top will give us minus 5 and the denominator will give us minus 5 as well. So that's just going to give us 1. So tan alpha is equal to 1, but we don't want tan alpha, we just want alpha by itself. So to find alpha, we're going to have tan inverse of 1, and you can pop that in your calculator and it'll tell you that it is 45 degrees. So the acute angle between those two lines is 45 degrees. Our second example asks us to find the obtuse angle this time between the lines 2x plus y minus 4 equals 0 and 5x minus 2y, that should be a y, hang on, so cross that out and write a y instead, plus 6 equals 0. So this time we're going to do the same working out, but there's going to be one extra step at the end because we want the obtuse angle instead. So we start off doing the same thing. We're going to rearrange them both into gradient intercept form. So rearranging this, we'd have y equals minus 2x plus 4. So that means our m1 is equal to minus 2. Rearranging this one's going to be slightly more complicated, one extra step. So we could rearrange that to 2y equals 5x plus 6. And then we have to divide by 2. So we'd have y equals 5 over 2x plus 3. So dividing both of those terms by 2. So that means that our m2 is 5 over 2. So now we can substitute in. So we're going to have tan alpha equals the absolute value of minus 2 minus 5 over 2 all over 1 plus minus 2 times 5 over 2. If you put that whole thing in your calculator, we'll end up with minus 9 over 8, which is, of course, the absolute value of minus 9 over 8 is just 9 over 8. So then to find alpha, we're going to have tan inverse of 9 over 8, which will give us, correct to the nearest minute, will give us 48 degrees and 22 minutes. So just be careful you don't actually round this off. So leave the whole number in your calculator. Don't round right until our final answer. So this is our acute angle. To find our obtuse angle, we're going to have 180 degrees minus alpha. So again, using that whole number in your calculator. And then we'll round off our final answer to the nearest minute, which will be 131 degrees and 38 minutes. So this is the obtuse angle between those two lines instead. So let's have a look at finding the angle between two intersecting lines.